Hey y'all, happy Tuesday. Welcome to Pre-Algebra with Miss Reeb. Today we're going to be going over the exit ticket from on Friday. But before we get started, I wanted to give you a little bit of insight about my weekend. So this weekend I was sitting out at the lake behind my apartment complex, and is that a turtle? Sorry guys, I was super distracted by that turtle. So anyway, I was laying out by my apartment complex and I was tanning, and I saw this sign that said, "Do not feed the alligator." And I was like, should I be concerned? That's kind of scary. Like, if there is an alligator, is it going to come get me? And so I just wanted to share that story with you about what I did this weekend. So at the end of this video, go ahead and comment in the comments section below. What did you do this weekend? So my hope is that this lesson kind of puts everything together from last week for you. We're gonna start with this problem from our exit ticket on Friday. Put the following numbers in order from least to greatest. The square root of 2, pi, 5, 1/2, and 39 over 9. First thing we want to do here is find the decimal expansion of each of these numbers. And decimal expansion is just the number written with a decimal and a bunch of decimal places after it. So for the square root of 2, we're going to use rational approximation. Rational approximation is I have my square root of 2. And I know that it falls in between two perfect squares. I know that the square root of 1 is a perfect square, and I know that the square root of 4 is a perfect square. So the square root of 2 falls in between the square root of 1 and the square root of 4. The square root of 1 is 1, because 1 times 1 is 1. And the square root of 4 is 2, because 2 times 2 is 4. So any number times itself gives you a perfect square. That means that the square root of 2 is going to be some number in between 1 and 2. So I am going to basically guess and check numbers to see if they're close. So I'm going to try, let's see, 2 is a little bit closer to the 1 side than it is to the 4 side. So I'm going to try 1.4 times 1.4, because remember, any number times itself is how you get a perfect square. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. X's and O's. 1 times 4 is 4. 1 times 1 is 1. I'll add them up. I have a 6, a 9, and a 1. And I see 2 numbers after decimals here, so I put 2 numbers after decimals here. 1.96 is pretty darn close to 2. So I'm going to say that the square root of 2 is approximately 1.96. Take a minute to write that down. The next number that we listed is pi, and the decimal expansion of pi is 3.14159, blah, 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 blah. It goes on and on forever and ever. It never repeats, and it never ends. So pi is an irrational number because that decimal goes on and on forever. But let's round it to, it's commonly known as 3.14. I am confident that if you were to put the number 5 on a number line, you would be able to do it. But I wanted to give you some practice with the word decimal expansion. So if you were to write the decimal expansion of 5, it would be 5.0000000 forever and ever and ever repeating. Because when you repeat that 0 in the decimal place forever, it doesn't change the value of the number. So the decimal expansion of 5 is 5.0, but I'm just gonna leave the number 5 because I know that you can place 5 on a number line. The decimal expansion of 1/2 is 0.5, and you can find that by dividing the 1 divided by 2. And I can show you that if you would like. Speaking of fractions, we also have 39/9, and I'm going to show you how to turn that into a decimal as well. So here we have 39 divided by 9. 9 doesn't go into 3 any number of times, but 9 does go into 39 4 times. 9 times 4 is 36. I end up with 3. I put in a decimal. 9 goes into 30 3 times. Minus 27 equals 3. Bring down a 0. Oh, I've already noticed a pattern. 9 goes into 30 3 times. These 3's are going to repeat forever and ever and ever. And this is a rational number because that 3 repeats forever and ever and ever. You can think rational ratio. If it can be written as a fraction, it is a rational number. So at the end of this video, I'm going to teach you how to turn 4.3 repeating back into a fraction. So now, as you can see, I have written all of these numbers as their decimal expansions, and now what I'm going to do is put all of these numbers on a number line to find out how they go from least to greatest, because our problem says least to greatest. So the first thing I'm going to do is draw a number line. And looking at these numbers, I know that I'm going to need values between 0 and 5. And I can label the rest of my line if I want. 1, 2, 3, 4, 5. And now what I'll do is I'll just put these numbers on the number line. So 1.6 is in between 1 and 2. It's a little bit past 1 1/2. So right here, I'm going to write 1.6, which is the square root of 2. .14 is just a little bit past 3. Here's my 3.14, which is pi. My 5 is going to go on the 5, obviously. This is 5. My 1/2 is 0.5, which falls somewhere between 0 and 1. Which is 0.5, which is 1/2. And 39 divided by 9 is 4.3 repeating, which is going to be somewhere in between 4 and 5, a little bit closer to the 4. So here we have 4.3 repeating, which is equivalent to 39/9. So now we have our numbers in order. 1/2, square root of 2, pi, 39/9, and 5. And that was your answer. So I know that you can go from a fraction to a decimal, but how do we get from a repeating decimal into a fraction? I'm going to show you this now. We've actually already had a couple lessons on this, so this should just be a quick review for you. So 4.3 repeating. The first thing we're going to do is say that x equals 4.3 repeating. Now I notice that there's only one number that is repeating over and over and over again. So I'm going to multiply both sides by 10 to the first power. And it's to the first power because there's one number underneath this bar. 10 to the first power is just 10, so 10x equals, in order to multiply by 10 to the first power, I'm going to move this decimal one place to the right, which gives me 43.3 repeating. And now what I'm going to do is I'll subtract x from this side, and I'll subtract 4.3 repeating from this side. And the reason that I can subtract x over here and 4.3 repeating over here is because I already said that x is equivalent to 4.3 repeating. So I end up with 9x equals 39. And now I want this x by itself, so I'll divide by 9. I'll divide by 9. And that is my answer, 39 over 9. And I also want to point out that 39 over 9 can still be simplified. I stopped here because that's what it is in my problem, but now I'm going to simplify as well. So in order to simplify a fraction, you're going to do the same thing to the top that you do to the bottom. So I'm going to divide the top by 3 and the bottom by 3. And I can do that because 3 over 3 is 1. 39 divided by 3 is 13. And 9 divided by 3 is 3. So if we were to take this number, this 4.3 repeating, and turn it into a fraction, you would only get partial credit if you stopped at 39 over 3, but you would get full credit if you kept going into 13 over 3.